Imagine a day unlike any other. The sun, usually a source of warmth and comfort, unleashes a blinding flash. This isn't just a solar flare, a common occurrence on our nearest star. This is much bigger. This is a superflare. Within minutes, communication systems across the globe begin to fail. Satellites, our eyes in the sky, go dark. Power grids overload and shut down, plunging cities into darkness. This is just the beginning. The superflare's charged particles are hurtling towards Earth at incredible speed. As the radiation hits our atmosphere, auroras, usually confined to the poles, blaze across the sky in vibrant, eerie colors. This beautiful display masks a dangerous reality. Our technological infrastructure, the backbone of modern society, is under attack. This is a stark reminder of our dependence on the sun and its unpredictable nature. We've all heard of solar flares, those bursts of energy from the sun's surface. But superflares? They're like solar flares on steroids. Imagine a flare so powerful it makes the most intense geomagnetic storms we've experienced look like flickers of a candle. Regular solar flares are impressive, but superflares take things to a whole new level. They release a mind-boggling amount of energy, equivalent to billions of atomic bombs detonating simultaneously. This energy, in the form of light, radiation, and charged particles, bursts forth from the sun in a spectacular display of cosmic power. The thought of a superflare might seem like something out of a science fiction movie, but the evidence suggests they're a real phenomenon, capable of wreaking havoc on our technological civilization. So how likely is it that we'll experience a superflare event? The good news is, they're relatively rare. But rare in cosmic terms is different from rare in our daily lives. Think of it like winning the lottery. The odds of winning are astronomically small. But every now and then, someone does win. The same goes for superflares. The chances of one happening in our lifetime might be low, but it's not impossible. Scientists studying distant stars similar to our sun have observed superflares happening. This tells us that our sun is capable of producing these events. While the exact probability is still under debate, the possibility of a superflare impacting Earth is a risk we can't afford to ignore. To understand superflares and other solar phenomena, we need to delve into the heart of the sun. Deep within its core, a process of unimaginable power unfolds: nuclear fusion. Imagine atoms, the building blocks of matter, smashing together with such force that they fuse, creating new elements and releasing tremendous amounts of energy. This is nuclear fusion, the engine that powers the sun. Every second, millions of tons of hydrogen are converted into helium in the sun's core. This energy, in the form of light and heat, gradually makes its way from the core to the surface, taking hundreds of thousands of years to complete its journey. It's this energy that sustains life on Earth and drives the sun's dynamic behavior, including the occasional superflare. The sun's magnetic heartbeat. But the sun isn't just a giant ball of fire. It's a complex and dynamic system, with a powerful magnetic field playing a crucial role in its behavior. This magnetic field is generated deep within the sun, created by the movement of electrically charged plasma. Think of the sun as having a giant magnetic heartbeat. Its magnetic field lines, like invisible threads, stretch and twist within the sun's interior. This constant churning and shifting of plasma creates a complex and ever-changing magnetic landscape on the sun's surface. These magnetic field lines are responsible for many of the features we observe on the sun, including sunspots, solar flares, and yes, even superflares. Understanding the sun's magnetic field is key to unraveling the mysteries of its most powerful outbursts. Sunspots and solar storms, blemishes and tantrums. Now let's talk about sunspots. These dark patches on the sun's surface might seem insignificant, but they're actually regions of intense magnetic activity. Sunspots appear darker because they're cooler than the surrounding photosphere, the sun's visible surface. Think of sunspots as temporary blemishes on the sun's face. These blemishes are caused by concentrated magnetic fields that rise up from the sun's interior, inhibiting the flow of heat to the surface. These magnetic fields can become twisted and tangled, storing enormous amounts of energy. When these magnetic fields snap and realign, they release their pent-up energy in the form of solar flares and coronal mass ejections. These events can hurl billions of tons of charged particles into space at incredible speeds, sometimes directed towards Earth. The solar cycle, the sun's rhythmic dance. The sun isn't content with just random outbursts. Its activity, including the frequency of sunspots, solar flares, and coronal mass ejections, follows a cycle, much like our seasons here on Earth. This is known as the solar cycle, and it lasts approximately 11 years. During solar maximum, the peak of the cycle, the sun is a hotbed of activity. Sunspots are abundant, and solar flares erupt with greater frequency and intensity. This is when the likelihood of a superflare, while still low, is at its highest. As the cycle progresses towards solar minimum, the sun gradually quiets down. Sunspots become less frequent, and solar activity diminishes. Understanding the solar cycle helps us anticipate periods of increased risk from solar storms and prepare accordingly. The Carrington event, a stark reminder. But what happens when a powerful solar storm collides with Earth? We don't have to look far back in time for an answer. In 1859, the Carrington event, the largest geomagnetic storm ever recorded, served as a stark reminder of the sun's potential to disrupt our lives. Imagine telegraph systems, the internet of their time, going haywire, sparking fires and delivering electric shocks to operators. Auroras, usually confined to high latitudes, blazed as far south as the Caribbean, painting the night sky with vibrant colors. While the world was a very different place in 1859, the Carrington event serves as a stark warning. A similar event today would have far more devastating consequences, potentially crippling power grids, disrupting communication networks, and causing widespread chaos. Understanding our star, the key to our future. The sun, our nearest star, is a source of life and energy, but it also holds the potential for disruption, even destruction. Understanding the sun's behavior, its cycles, its flares, and its storms is crucial for safeguarding our technological civilization. Scientists constantly monitor the sun, using sophisticated instruments both on Earth and in space. They track sunspots, solar flares, and coronal mass ejections, issuing alerts and providing crucial information to power grid operators, satellite controllers, and other stakeholders. By unraveling the secrets of the sun, we can better predict and mitigate the risks posed by its powerful outbursts. This includes developing more resilient power grids, designing radiation-hardened satellites, and improving our space weather forecasting capabilities. The future of our technological society depends on our ability to live in harmony with our nearest star.